Hey everyone, welcome back. Today we're diving into a topic that bridges the worlds of machine learning and old school statistics, multiple regression. Then we're going to deep dive into the regression itself as a quick extension of our previous discussions on bivariate regression. So whether you're a data scientist, a statistician, or just curious about how we predict things based on multiple factors, this is for you. Let's break it down together. So here's the big idea. Multiple regression is simply a way to model the relationship between one variable and several explaining variables that might move it or predict it or what have you. And here's where it gets interesting. In old school statistics, we talk about linear models, coefficients, p-values, r-squared, you get it. In machine learning, we say things like features, model training, loss functions, optimization, etc. Different languages, but under the hood, it's the same core math. Let me show you. In both worlds, the linear regression equation looks like this. Y equals a linear combination of x's times their coefficients betas. So y is called the dependent variable, also called the target in machine learning. x1, x2, all up to xp are the independent variables or the features or inputs in machine learning. Betas are the coefficients, or they're called weights or parameters in machine learning, and epsilon is the error term. In statistics, we'd say we're estimating the parameters beta to understand relationships and test hypotheses. In machine learning, we say we're fitting a model by minimizing a loss function like mean squared error to make predictions. Same math, different goals. So let's run through a quick jargon breakdown. So in this first column over here, you got your old school statistics. In your second column are the terms used in machine learning. Again, like we said a while ago, dependent variable is called target or label in machine learning. Independent variable is called features. The observations or data points are called instance or example. The model coefficients are called model parameters in machine learning. In statistics, we say model fitting, and in machine learning, we say model training. Then we got your predictions for both sides, the fitted value or the output in machine learning. And then we go down over here to the assumptions of linearity, normality, and homoscedasticity in statistics. But in machine learning, they're often ignored. You're really more concerned about how good your predictions are. In the end, it's all about fitting a line that best captures the relationship between variables. Now, additionally, we have to make a core distinction. Regarding supervised machine learning, we got two terms actually called regression and classification problems. So in supervised learning tasks, you got regression problems where the target y is a continuous variable. Example are stock prices. And then classification problems, you got y as a categorical or ordinal, like fraud detection, credit rating, and so on and so forth. So in traditional statistics, the underlying procedure might still use linear regression to come up with the categorical output, like accept or reject, pass or fail. So in a sense, they're still considered linear regressions. However, in machine learning, you look at the target, aka the dependent variable. And if it's continuous, it's called a regression problem. And if it's categorical or ordinal, it's a classification problem. Regardless if the underlying procedure looks like what's called regression in traditional statistics. Finally, all multiple regression models under traditional statistics can be considered a type of machine learning regression when used for predictive modeling, but not all machine learning regression models are multiple regression models. So remember, regression has a particular sense in machine learning, and it encompasses a wide range of techniques, some of which go beyond the traditional assumptions and limitations of multiple regression in statistics. But just for this issue of multiple linear regression, it's the same thing, but framed differently in terms of the goal. So how do we do the multiple regression model? In terms of the actual ordinary least squares regression, we simply use our old formula, but we will expand this to include additional independent variables. And there you go. You already have it automatically. It's already considered by how we did things before. Additionally, we'll now use VBA to work this to make the computation simpler, and the code is exactly what we used before in the bivariate case. Only now we have a bigger data range for matrix X versus before. And we're providing a link below so that you can visit that old episode on bivariate case. So whether you call it multiple regression in statistics or linear regression model in machine learning, The underlying math is the same. It's just that statistics is often about understanding and inference, while machine learning is more about prediction. Different focuses, same equation. So if you found this helpful, give us a thumbs up and don't forget to subscribe for more insights, as we'll be doing more deep dives into the applied side of all this quant stuff. Thanks for watching. See you in the next video.